All right, before we get into problem one, I just want to walk you through how to analyze a table like this. And so solubility table, we have this side. This has our always and usually soluble anions. That's what it's based around, the negative part of the ionic compounds. And this is based around our insoluble, usually insoluble anions. So first, let's go through here. So we have nitrate and acetate. There's no exceptions. All nitrate and all acetate salts are soluble. Then we have our usually soluble. So for chloride, bromide, and iodide, the vast majority of the metals, if they form an ionic compound with one of these, it will be soluble, with the exception of silver, lead, and mercury. So for example, silver iodide or lead bromide or mercury chloride, those are insoluble. And then sulfate. The vast majority of metals with sulfate will be soluble. However, silver, lead, mercury, insoluble. And this for sulfate, there's two more. Calcium and barium are also insoluble. So barium sulfate, calcium sulfate, silver sulfate, all of those are insoluble. There's no anions that are always insoluble, and that's because if we have ammonium, lithium, sodium, potassium, rubidium, or cesium, any of those cations with any of the anions, it makes it soluble. So there's no anions that are always soluble. And then finally, usually insoluble. So sulfide, which is S2 minus, is usually insoluble, and the only exceptions are these guys down here. Okay, ammonium and then the alkali metal cations. Same deal with phosphate. With phosphate, they're usually insoluble, so the vast majority of the periodic table, when it's with phosphate, is insoluble, except for these exceptions again, ammonium and the alkali metals. For hydroxide, there's very few exceptions, except for barium, and then these usual suspects again, ammonium and the lithium, sodium, potassium, rubidium, cesium, the alkali metals. All right, how you want to focus yourself when you look at these is to look at the anion, which is always second, and then look at the chart. So this is magnesium 2 plus with S2 minus, so it's a sulfide. Sulfide is usually insoluble. What are the exceptions? None except, and magnesium's not listed here, so it is insoluble. All right, nitrate, NO3 minus. Nitrate salts are always soluble. There's no exception to that rule, so this is soluble. Chloride salts are usually soluble. The exceptions to that rule are silver, lead, and that's lead, so insoluble. Hydroxide salts are usually insoluble. Barium, however, is an exception, making it soluble. Chloride salts are usually soluble. All sodium salts are soluble, so this is really, really soluble. Sulfate salts are usually soluble, and copper is not in the list of exceptions, so it remains soluble. Phosphate salts are usually insoluble. There are no exceptions except for these guys, and silver is not listed down here, so this phosphate salt is insoluble, as most of them are. And then finally, this is a nitrate salt. Nitrate is always soluble, and so that compound is soluble.